Hi, I'm Akmal Said, and I'm a sales engineer here at Wallaroo AI. In this video, we'll explore how to apply MLOps to a forecasting model using Wallaroo. Forecasting is critical across industries, helping businesses anticipate demand and make data-driven decisions. Today, we'll focus specifically on time series forecasting with Facebook's Profit Framework. We'll demonstrate how Wallaroo's Bring Your Own Predict framework, also known as BYOP, allows us to train and forecast a custom profit model with a single inference call. Then, we'll go over how to scale that same workflow to train and forecast a million bespoke profit models with minimal effort. Finally, we'll cover orchestration, Wallaroo's solution for automating end-to-end workflows. Let's get started. Once we're connected to our Wallaroo client and our Wallaroo workspace, we'll see how in 3 steps we're able to deploy our custom profit pipeline. In this first step, we upload our custom model using Wallaroo's flexible BYOP framework. This framework allows us to seamlessly integrate our custom profit workflow. I've already unzipped the contents of the custom profit workflow. Inside the main Python file, we can see Wallaroo's BYOP framework in action. By utilizing the BYOP template, we can take our standard profit workflow, something we've already tested outside the framework, and paste it into the predict function. As we can see, we have it set up to use incoming data to both train and generate forecasts with a bespoke profit model. Back in our notebook, we specify the framework to be of type custom when uploading the model to Wallaroo. Having uploaded our model, we're now ready to move to our second step. In our second step, we configure our deployment hardware. Wallaroo being installed on Kubernetes, this abstraction simplifies the process. We specify the number of CPUs and memory we want to allocate to our model. Wallaroo makes this easy with fine-grained control, even allowing us to allocate fractional CPUs. Once we're finished with our configurations, we can move on to the third and final step. In this final step, we deploy the pipeline using the uploaded model and our configuration settings. The deployment process takes around 45 seconds, and Wallaroo handles everything from containerizing the model to managing the pipeline infrastructure. Once deployed, we can test our pipeline by calling the infer function with our historical data. As expected, the profit model returns a forecast in the form of a data frame. Once we're done testing our deployment, we can get our pipeline endpoint's URL, which we can then use to make API calls. And that's how, in 3 steps, Wallaroo helps us deploy a custom workflow which trains and forecasts a bespoke profit model. And so we've deployed our pipeline, and we see that inferring with a single record trains and forecasts one bespoke profit model. But what if we need to scale this to handle multiple models? That's where Wallaroo's support for batch inferencing comes in. With batch inferencing, we can train and forecast a bespoke profit model for each record in the batch. The best part? We can use the same infer function we saw earlier to handle multiple records in one call. By inferring on a batch of records, we get a separate forecast for each record returned. And that's how Wallaroo's batch inferencing enables us to efficiently extend our pipeline to train and forecast multiple bespoke profit models. Now, in practice, forecasts are often made at different granularities. A comprehensive forecast typically aggregates thousands, sometimes millions of smaller, more granular forecasts. We just saw how Wallaroo's batch inferencing can be used to train and forecast multiple bespoke profit models. However, those inferences were performed sequentially. While this approach works, it can be inefficient for large-scale forecasting scenarios. The good news is, with Wallaroo's parallel infer function, we can run those inferences in parallel, speeding up the process. By combining it with Wallaroo's ability to deploy multiple pipeline replicas, we can just as easily train and forecast multiples of those more granular bespoke profit models in a fraction of the time. Deploying multiple replicas is the same process we saw earlier. Thanks to the flexibility of Wallaroo's deployment configuration, adding replicas to our pipeline is as simple as adding one extra function call. The replica count function allows us to specify how many replicas of our pipeline we wish to deploy. Next, let's look at parallel infer, which is similar to the infer function we saw previously, but with a few additional parameters. The most important one to note is num_parallel. It allows us to define how many parallel inferences we wish to run. By simply replacing our infer function with parallel infer, training and forecasting with a million granular profit models, for example at the store SKU level, which are then aggregated into a unified forecast, becomes much more efficient. With this setup, we can see that by using 100 replicas of our lean pipeline, it takes just over an hour and a half to train and forecast with a million bespoke profit models. To illustrate the time savings, had we not taken advantage of the pipeline replicas and parallel infer, the same process would have taken us nearly 56 hours. Having explored how to train and forecast with a million bespoke profit models, you might be wondering, is there a way to automate this entire forecasting workflow? The good news is, with Wallaroo's orchestrations, we can do exactly that. Wallaroo's orchestrations allow us to move from manually running forecasts to automating them on a customizable schedule that aligns with our business needs. Better yet, by integrating them with Wallaroo's connectors, we can connect to cloud databases, enabling us to pull and push data for continuous analytics and reporting. Let's walk through the process. First, we upload our orchestration. It's a zip file containing our forecasting workflow and any necessary artifacts. Once uploaded, we have the option to schedule the orchestration. This allows us to automate our workflow to run at regular intervals that align with our business needs. Whether that be nightly, weekly, or another frequency, scheduling the orchestration ensures our forecasting process is automated and consistent. Alternatively, we can trigger our orchestration to run on demand. In this walkthrough, we cover how to schedule and execute our orchestration using the SDK, but it can be done just as easily via the UI. When executing the orchestration, we specify the Wallaroo connector name configured earlier. This connects us to our cloud database, allowing us to read and write to it. Running the orchestration creates a task which we can monitor in real time. Let's head to the Operations Center to see how we can track this task. The Operations Center is a central way to manage multiple deployments with Wallaroo. From here, we can view uploaded models, active and inactive pipelines, and orchestrations. To check the status of our orchestration, we go to the Workloads tab, where we can see both active and inactive workloads. By clicking on the orchestration task we just ran and navigating to the Task Runs tab, we can view detailed logs of the task's execution, including its completion status. As we can see, our orchestration ran successfully. What's even better, we can also access these same logs programmatically from our notebook using the Wallaroo SDK. Finally, leveraging Wallaroo's connectors, we can pull the forecast results directly from our cloud database and plot them as needed. In summary, with Wallaroo's orchestrations and connectors, we've automated our forecasting workflow and ensured that our forecasts are always powered by the latest, most accurate data. And with that, we've seen how, with the help of Wallaroo, we were able to seamlessly deploy our custom profit pipeline to the cloud. We also saw how Wallaroo simplifies scaling by creating multiple pipeline replicas. Combining that with parallel infer, we were able to efficiently train and generate forecasts for 1 million granular bespoke profit models in a fraction of the time, allowing us to then use these individual forecasts to be aggregated into a unified comprehensive forecast. Beyond deployment, Wallaroo's orchestration and connectors allowed us to automate our workflows and integrate with our broader cloud infrastructure, ensuring our forecasts stay up to date with the latest data while providing comprehensive logs for tracking task status and progress in real time.